Okay, so in this week's design challenge, your goal is to make a demodulator circuit, right? We talked about AM radio and how there's a carrier frequency, and then how a signal is transmitted by modulating the strength of that carrier frequency. Those modulations correspond to the signal that we're actually interested in. So what we're going to say is that we now have a signal which is going to have that modulated carrier frequency, and what we need to do now is build a circuit to recover the signal, the song, or the audio stream that we're actually interested in, right? Okay, so our goal here is now a demodulator circuit. Okay, and what you're going to need for this one are several different components, as you always do in these design challenges. So we're going to need a component that suppresses the carrier frequency. Right? We've got this high frequency carrier signal, and we want to get rid of that, right? Because we're not interested in terms of what's actually being transmitted. Okay? We want something else that is going to rectify our signal. Okay? Because what we're interested is in the envelope of the modulation of that carrier frequency. So we want something that's only going to look at just one side of it, something that's always going to be always positive. And in principle, we could just use a diode to do this, but we're going to show you just in kind of schematic out a circuit for a precision rectifier using op-amps. And we're going to walk through that in some of the documents we give you. Okay? And then finally, you're going to need something to low-pass filter this rectified signal. Okay? So something, and then the idea is that this low-pass, this filtered signal is going to give us the information about the actual signal, the modulation of the amplitude of that carrier frequency. And the goal here is that you should be able to recover the signal that's being transmitted in this modulated signal, as is done in AM radios, right? Okay, so why don't you go ahead and get started.